So my name is Augustinas, and why you should listen to me. Right, so in the last 10 years, I worked at Barclays in virtualization platform engineering, and there was a lot of VMs there, a lot. So there were very interesting challenges while keeping VMs cost effective and providing adequate performance. So then I joined Danske Bank just in time for the great migration that now Mantas is trying to kind of get rid of. It's kind of sad. I also participated in Cloud 2 journey, and I saw there quite a few Danske Bank engineers here. So if you ever wondered why availability zone 2 is in a data center 1, that's my fault, okay? All right. So in Danske Bank, I kind of had a first date with Kubernetes, OpenShift, and kind of never looked back. Then I joined CAST as a first employee. So we built automation for Kubernetes, and today we manage thousands of Kubernetes clusters, and we add, remove millions of Kubernetes nodes every month. So quite a scale. All right, so while we're talking about Kubernetes, the whole theme was about VMs, right? So if we look like 7, 8 years ago, there were about 20 container orchestration platforms out there in the wild. Most of them died out. Kubernetes is like 90% of the market. So if you're not doing Kubernetes, you're doing something wrong. If you can migrate out of VMs, right? So is Kubernetes kind of heals cancer and everybody should start using it, as this tweet shows kind of? There's a bit too much hype around it, and my personal opinion, you have to have basic 2 requirements to use Kubernetes. So first, your IT maturity should be, you should be able to walk, but if you're at the crawling stage or just laying down dead, you're not ready for Kubernetes. Meaning, you should be capable of doing infrastructure as a code, packaging applications to containers or functions, know what is observability stack, and etc. Right? Second reason is to take benefit of Kubernetes, you have to have bare minimum of a scale. I would say that's about 20 CPUs, where it makes sense if you do something very small on the edge, probably it's not worth it, right? So I asked ChatGPT, because it's a trend, right? What are the most best reasons to use Kubernetes? So vendor neutrality, very good. It provides ultimate portability, consistency, self-healing, scalability, all good. Faster time to market, maybe. It requires a lot of upfront investment, so you can go fast, right? But it's not the best tool to drop through the door fastest. Cost efficiency, better resource utilization, that's kind of stretching. I call bullshit on it. And why Kubernetes is not most cost-effective platform for compute, right? Because it's not that all the previous tools or platforms we had that were more cost-effective. It's just because Kubernetes removes gap between application owner and infrastructure, there's less space for manager, FinOps, budget owner to inject themselves to be in control. And then you get t-shirts like this, right? Application owner writes YAML code, and on the other you get cloud bills, right? So according to Datadog, half of application barely using any resources, and half of your cloud bill is basically waste. And it's a $300 billion problem, and it's getting worse. All right, so let's go to the main dish of my talk, and I'm going to talk about Kubernetes layers. It's going to be a bit technical, so keep up. So you should think about Kubernetes as box inside the box inside the box inside the box, as a Russian matryoshka, right? And basically, you cannot shrink upper box if smaller box inside is not small enough, right? So imagine you have Kubernetes cluster with 100 processors, 400 gigs of memory. Those are the real physical things. You actually go to OpenShift and Danske Bank data centers or AWS data center, and you can touch these things. Those are real things that you're paying money for, these things appear in your cloud bill, so it's a real world. All other layers that I'm going to talk are digital, virtual, imaginary. So this is most important layer because you are being charged money for this layer, right? So if I have Kubernetes cluster with 100 CPUs, why can't I just cut in half, right? Just push the box down to half capacity. Well, then you broke boxes inside. Half of your application stopped running. You're probably not going to do that, right? So you have to shrink the box until you reach the smaller box inside, right? Or you can make these 100 CPUs and 400 gigs of memory a bit cheaper. So there's many ways you can build your Kubernetes cluster to achieve that capacity of 100 CPU. So the most simplest and worst case, you kind of like pick one VM type, like 4 CPU, 16 gig of memory, make 25 of them, you have reached that capacity, right? But then there are many different ways how you can combine different VM types and achieve same result or better result. So if you go to AWS, you will find that in each availability zone, there are over 500 instance types today. So you have to make a decision, well, what kind of VM I need, right? And it's not trivial. There are a lot of dimensions, but like rule of thumb, newer generation VMs provide better bang for the buck because Moore's law, right? So then you have to kind of understand what's your CPU memory ratio, and it's especially complex in Kubernetes because in Kubernetes cluster you have a lot of applications. Some of them using a lot of memory, some of them using barely any memory and using mostly CPU. So you have to plan for the group, and then if you don't, you end up situation where like memory is fully used on a node, there's no capacity for CPU and vice versa, so you have a lot of wasted resources. Other extra dimensions like VM sizes up inside the family, or other dimensions like special hardware, like can your applications run ARM instances, need GPUs, inference CPUs, SSD disks, locals, and etc. So there's a lot of dimensions. Because there are so many, it's unreasonable to think that people can make a good decision manually to do that. So it needs to be automation to react what is deployed inside your Kubernetes cluster, right? So it requires automation. All right, so I have an example that I'm using different kind of VMs to achieve 100 CPUs, so this is one way to do it. So other way to make, so basically because I chose VMs which provide better bang for the buck, these 100 CPUs are already cheaper because I use a mix of different instance types. Also, it's possible to use not only on-demand instances, which is basically you pay, you get these VMs until you pay, and they will not disappear or anything, or you can use spot instances. That means you get VMs for 70, 80, 90% discount, but the catch is they will disappear with 2-minute notice, meaning the requirement for your IT maturity, you have to be able to sprint. Your applications need to be able to survive that half of a cluster capacity just disappeared, right? You have to avoid that, right? And it's a hard problem. So, and the third is, I think it's the most popular worst solution today that is kind of practiced, is where desperate product budget owners, managers, FinOps people spend most of time. They just go commitments, right? So they go to AWS and saying, I'm gonna commit to use this VM for 1 or 3 years, and I can even pay cash up front. So the more you commit, the more money you pay to AWS up front, the bigger discount you get. But then why did you go to the public cloud if you're just, you have CapEx there, right? You're paying that money, you could have just bought double capacity in private data center. It makes no sense, right? And recently, AWS and Google kind of changed legal terms so you cannot resell your reserved instances. Basically, if you make a commit for certain VM types, you have to go use them till the end, right? And if you're buying reserved instances, you're basically betting your money against Moore's law, the same law that is 70 years still alive and kicking, right? That every year compute becomes cheaper and more performant. So savings plans are, I would say, is quite good thing as long as you don't go too much over it, right? And you go with a flexible savings plan. So quickly recap, use automation to decide which VMs your cluster need. Don't use reserved instances, those are evil. Use savings plans, which are flexible. All right, so this is the first layer. So quickly going over second layer is, so in a public cloud, when you see VM that has like 16 gigs of memory, you launch it, you look inside, there's no 16 gigs of memory, it's like 14, maybe 13. So it's a bit inconsistent, so there are traps in the cloud, you have to be aware of those. So if you're plan to use AWS the most, I would especially suggest to avoid burstable instances. Those are VMs that look the cheapest, but they provide complete rubbish performance. And if you use them, if you increase utilization in them, you have to buy CPU credits, and they become most expensive VMs in the cloud. So basically, you get bad performance for ridiculously high price. Another problem with this is that if you have a lot of small VMs in your Kubernetes cluster, daemons such as helper applications like provides observability, logging, network or security, those can eat up your like lion's share, like 1/3 of your cluster capacity can be eaten up by helper application, not solving business problems, right? All right, let's go to talk about our, I'd say, biggest spend in Kubernetes cluster, or where the most fat lies. And I have an analogy here, but before we go analogy, I quickly explain the terms. So Kubernetes node is a VM, right? Same VM as you run. So let's assume in this analogy that Kubernetes VM is a train coach wagon, right? Kubernetes scheduler is a Kubernetes component which basically tells application to which wagon to go. And applications in our case, Kubernetes pods, are passengers. So here's the analogy. So train moves fully booked, seating all people, passengers sitting in all seats. Train moves from Vilnius to Biržai, right? So with every stop, more passengers get off the train than get in. Over time, half of your wagons become half empty, right? But because Kubernetes scheduler doesn't care about passengers in a train, nothing will move these passengers between wagons. You would be able to kind of ditch few wagons because they're barely utilized, but nothing in Kubernetes will do that. So that's the real problem, and it's very hard to solve. So basically, going from analogy, you have VMs. On VMs, you have random workload distribution. It might be that your average utilization on node is like 20%, but nothing will kick these nodes, right? And one of the reasons is because Kubernetes is actually not designed for cost efficiency or better resource utilization. Kubernetes was designed for consistency, meaning you asked for resources and you have a hard kind of guarantee that you will get enough of them. So basically, if your application finishes work, random application will terminate. It will not try to make some nodes empty so you can reduce these nodes. That's why it's so hard to remove nodes that are barely utilized. So when you're scaling back application, Kubernetes scheduler will try to find the emptiest node and place application there, meaning it's the least cost-effective Kubernetes scheduler solution in the world. And the worst, if you're using public cloud Kubernetes, you cannot change this behavior because Kubernetes scheduler is part of a control plane, and control plane is behind AWS doors, so you cannot influence. All right? So what you can do is, imagine you have the train with the passengers, and some businesses decide that they want special, like business class, premium class, economy class, class with kids and animals, right? So you have basically, you segregated train into smaller parts, and you can, and this segregation causes, it's basically very expensive. So if you say, let's say like finance team in Danske Bank saying, we have some imaginary compliance requirements and we cannot run on the same hardware as some other business department, that segregation is extremely expensive, and you should fight in this organization and everywhere not to segregate compute by imaginary reasons. So one of the reasons that people believe they have to have segregation is for cost of visibility, because in AWS, Cost Explorer doesn't look inside Kubernetes. So you kind of create these silos of resources, towers of smaller boxes, so you could see the cost attribution, but it's extremely expensive, and there are better tools that will allow you to look inside so you can attribute the costs. So fight with everything in the organization not to create these silos of resources, right? All right, so last layer I want to talk is application sizing. And Kubernetes works in a way as a saying, you tell to Kubernetes in the request field how much CPU and memory your application needs. Kubernetes doesn't care how much resources you're going to use, not one bit, right? And as application owner, you have usually absolutely no incentive to make sure that these numbers are accurate. So as I showed Datadog slide, Datadog saying that those numbers are like 3 times over than they actually needed, right? So you have to size your application correctly, and nothing inside Kubernetes will help you to do that. And so what I meant by sizing applications, you have to size application vertically. One copy of application, as application owner, you have to set how much it needs CPU and memory. And the hard part is that your applications are usually live beings. They're being developed. If they use that much CPU memory today, maybe users' patterns will change. Maybe you're going to release new features, and the behavior of the application will change. It will need more RAM or more CPU, and etc. And you have to basically constantly adjust that. So there are open source tools like VPA and Goldilocks that will help you kind of do that. It's painful, but it's possible. Once you adjusted application requests, so it requests amount of resources that you actually needed, then second you have to do is horizontally scale pods based on business metrics. There's also no incentive for engineers to do this dynamically, because why risk being cost effective? Because you're going to have on-call, you have incidents, you have to wake up in the night, and it's lose-lose-lose, right? Just increase 5 times than you need it, and no worries, right? But in well-run organizations, you have to dynamically scale your applications. And one of the best tools in the market is KEDA. It's listed. It basically, you don't look at CPU or memory utilization. You scale based on business metrics. That could be SQL query or SQS queue, and etc. And those could be like number of users that are using our product, or number of items in a cart or something. Business metrics that would create as many copies of your application based on these business metrics. So when you put all these learnings together, you should get yellow curve that basically in the morning, because for instance, Danske Bank users are in Europe, you should increase the dynamic number of applications, replicas running, so demand for a compute increases. And then, for instance, there's a drops in the evening, and the number of resources requested should drop radically as well, right? So, and for instance, in this case, so blue line is provision capacity. You could achieve kind of this result with open source tools like Cluster Autoscaler, or you can, if you do a better job, you can achieve like this, where blue line will mimic your yellow line, provision capacity and requested capacity, so that your cluster expands and shrinks in a few minute kind of window, and you don't overspend. And you can basically save costs. I don't know, we have customers that receive probably 90% and etc. So scale your applications based on business demand, do automation, don't let FinOps commit into future that will lock you from solutions in the future. And this example how your cloud bill can shrink when you enable automation. So that's my talk. Any questions?